This is section P.1, Algebraic Expressions, Mathematical Models, and Real Numbers. If a letter is used to represent various numbers, it is called a variable. A combination of variables and numbers using the operations of addition, subtraction, multiplication or division, as well as powers or roots, is called an algebraic expression. Evaluate an algebraic expression means to find the value of the expression for a given value of the variable. Exponential expression. The b here is the base. Expression. Again, to evaluate an algebraic expression means to find the value. Variable x has a given value of 13. We're going to go ahead and replace the order of operations. We have to go ahead and evaluate inside the parentheses first. So I get 9 plus 7, and inside the parentheses, 13 minus 4 is 9, and that is squared. What I did first was the parentheses. Then we want to go ahead and evaluate any x. So 9 to the second power, just 9 times 9, which is 81. So I have 9 plus 7 times 81. The parentheses there indicate multiplication. Now the next order of operation is multiplication or division from left to right. And that means if you see multiplication and division in your problem, you're going to do whichever operation you see on the left-hand side first. Well, in this case, I only see multiplication and addition, so multiplication is what we're looking at now. Go ahead and do that. Okay, if you don't have a calculator, you can go ahead and do by hand. And again, the last order of operations step would be addition or subtraction from left to right. In this case, all I have left is addition, but if I did the subtraction, you would do whatever you see on the left-hand side first. So I'm going to take 9 plus 567, and I get 576. Okay, so notice how in this example we had a value for the variable, we put it in the expression, and we got it. Okay. The next definition is one definition that I get a lot of students confused on throughout the semester, and it's the definition of what an equation is. So an equation is formed when an equal sign is placed between two algebraic expressions. So algebraic expression, let's say we had 3x plus 4. That's an algebraic expression. And let's do another algebraic expression, let's say 7x. Once I place that equal sign in the middle, that's when it becomes an equation. So when you look at your exams or your tests, just make sure, or your homework, that make sure that you understand whether you have an expression alone. An expression alone would just be the 3x plus 4. That would be an expression. In equations, when you have an expression equal to another expression, and that's what really hard for a lot of students to see. A formula is an equation that uses variables to represent or to express a relationship between two or more quantities. The process of finding formulas to describe real-world phenomena is called mathematical modeling. Such formulas, together with the meaning assigned to the variable, are called mathematical models. Okay, this is example 2. The formula t equals 4x squared plus 341x plus 3,194 model the average cost of tuition and fees, t, for public U.S. colleges for the school year ending X years after 2000. Use the formula to project the average cost of tuition and fees at a public U.S. colleges for the school year ending in 2015. Okay. Now, depending on when you're watching this video, 2015 is currently now or it's in the past. But in this case, we're looking at 2015, and 2015 is actually 15 years after 2000. So X would now represent 15. So now we're going to go ahead and project the average cost of tuition and fees for the school year ending in 2015 by using the formula T equals 4x squared plus 341x plus 3,194 plus 3,194. So we're going to go ahead and do our order of operation, then we're going to go ahead and do the exponential expression first. So 15 squared is basically 15 times 15, and I get 225. And then drop the rest of the problem down. And I go ahead and do my multiplication next. So 4 times 225 gives me 900. Plus 341 times 15, I get 5,115 plus 3,194. So now I'm going to go ahead and add those numbers together, and I get 900 plus 5,000. I get 9,209. So let's look at what we really discovered here. We discovered that the average cost of tuition and fees for the school year ending in 2015 would be 9,015. But what would happen, and what would the average tuition be for the school year ending in 2045, so 30 years later? And I think you could guess that it definitely would go up based on what's been happening currently. So let's go ahead and find that out. So T would equal plus 340. If you have the TI-30X2S calculator I had y'all purchase, you can actually go ahead and type in this entire problem in the calculator. Type in 4 parentheses 45. I use the square button, which is on the left hand side. 1, 2, 3, 4, 5, 6 parentheses 45 plus 3194, and I get T equals 26,639. So you can see a definite jump between those 2 years, those 2 different school years. So $9,209 for 2015. 30 years later, same school pretty much, or the same, where the average tuition for U.S. colleges is a significant amount more. And so this would be $26,639. Okay, I won't write a sentence out for that, but you would basically say the average cost of tuition and fees at a public U.S. college for the school year ending in 2045 would be $26,639. Okay. Okay. Next thing we're going to look at is the number line, and what we're going to do is we're going to start looking at some symbols, and we're going to look at the following inequality. And so the following inequality symbol, we have the less than sign, or inequality symbol. We have the less than or equal to. We have the greater than and the greater than or equal to. This one's less than. This one is less than or equal to. These symbols always point to the lesser of the 2 real numbers, we say smaller, and open to the bigger or greater. Of the 2 real numbers when the inequality statement is true. So I always tell my students, and I go back to what I learned in grades, be true. It opens up to the 8, which is bigger, and it points to the smaller number or the lesser number of 1. Also note the number line, we'll talk more about this later. When you look at the number line, all the smaller numbers are always going to be on the left-hand side, and all the larger numbers are always going to be on the right side. So you're trying to compare -7 and -3. Well, -3 is going to be larger because it's closer to the right-hand side, or it's on the right-hand side of -7. It's all the closer to 0. Okay. Another thing we'll talk about is the absolute value around is the distance from 0 to A on the number line. The distance is always taken to be non-negative, which means positive. Distance -3 is to 0. 1, 2, 3. So 3 units away. The absolute value of 3 to 0 is going to be 1, 2, 3. It's still 3 units away from 0. The absolute value of 9 is going to be 9 away, and the absolute value of -9 is going to be 9 away. Notice how all the absolute values are going to be positive. Now, I didn't make you buy a book for this course, but if you open up your textbook or go to the multimedia library, on page 12 there's a list of properties of real numbers, and you should know the meaning of each. A lot of these are pretty self-explanatory, and I'm going to open up my book to kind of look at them with you. Again, you can go to your multimedia library if you don't have a textbook, and on page 12 they have all the properties of real numbers. A couple of them are the identity property of addition. If you add 0 to any number, you get your value back. That doesn't change anything, and so on. We have a couple that I want to go over. The commutative property of addition. And what that means is that changing order doesn't matter or affect in the answer in addition. So when I think of the word commute, I think of a commuter and moving, and what basically saying is moving or changing the order of your addition problem doesn't affect the answer. So let's say I have 5 plus 3. Does it really matter if I say 3 plus 5? Does that change the value of your answer? And it doesn't. So in addition, we can always change the order. Another one I want to make sure that we all know, and again, I'm not going to ask you these names on the test. They might ask you these names or to recognize these names or the name of the properties on your homework, but I really want you to understand that when you add two numbers, it doesn't matter what order you add them. Same thing is true for multiplication. So let's say I have 5 times 9, 9 or 9 times 5. So that works also on multiplication. Now, there's no community property of subtraction or division because when you subtract or divide, the order does change the value of your answer. Of addition and multiplication. Multiplication. Let's do the addition one first. What this basically means is changing grouping when adding does not affect the sum. So let's say I have 5 plus 2 plus 1. And let's say a student goes, well, I want to go ahead and do the 5 plus 2 first and then add the 1 later. Let's see what happens. So let's say I have a student named Bob, and Bob says, I'm going to add 5 plus 2 first and then add 1 later. When I add 5 plus 2 first, I get 7. And I add the 1 later, I get 8. Let's say sit next to Bob first and then worry about adding the 5 later. Well, what happens when you do that? 2 plus 1 is 3, and I worry about adding the 5 later, I still get 8. So associative property addition just basically means that when you change the grouping of adding, it doesn't affect the sum. So if you have 5 numbers and you're adding together, it doesn't matter which 2 you add first. Okay? And we usually indicate grouping by the parentheses. We also have the associative property of multiplication. The same idea applies. So associative property of multiplication. The same idea applies, because we're just going to use multiplication as our operation. So let's say I have 5 times 2 times This is my number 4. And I have 5 times 2 times 4. And again, 10 times 4, and I get 40. Okay. And Shelley says, well, I'm going to do the 2 times 4 first, and worry about multiplying by 5 later. Well, she'll get 5 times 8, and she'll still get 40. Okay. Now, this does not work in a subtraction or division. If you try it, you'll get different answers when you change the grouping. Okay. Again, I'm not going to emphasize knowing the names of these properties. Just know that they work for addition and multiplication. One property that is super, super important to know by name is the distributive property of multiplication or addition. We use this property a lot in this class. You probably used it a lot in your other algebra courses. When you have addition and you have multiplication over it outside the parentheses, you can actually distribute that and do that over the addition. So what I really get is A times B plus A. I generally tell my students I like to kind of prove why this works and why we use this and when we don't use this and why we would use this. So let's go to a problem where we would go back to our pre-algebra days, and let's say I had a problem where I had multiplication over addition. Let's say I had 5 times 2 plus 1. Okay, let's put some space here. So this is our pre-algebra days, before we even knew about distributive property. Okay, so not using distributive property. If I were to do this problem back in pre-algebra, we would follow the order of operations, and we would say 2 plus 1 inside the parentheses goes first. If I get 3, I drop down the 5, and I drop down the parentheses. So I did my parentheses first, and then do multiplication next, and I get 15. Now let's do the same problem, and let's use the distributive property. So use distributive property. You should get the same answer. So what I do is I take 5 times 2, so I get 10 plus 5 times 1, which is 5, and I get 15. I get the exact same answer. And so you might be asking me, why do we use the distributive property? Well, when we just have numbers, and like we just had an example here, really you probably would use the order of operation. But later on we're getting to problems where you have something like, let me get a different color here, 5 times 4. They're not like terms. The only thing we can do here is we can use distributive property, and we can do the multiplication over addition. Okay, that would be what? 5 times 3x plus 5 times 4, which is 15x plus 20. That's when we have to use distributive property. There's no way to add inside the parentheses. So we'll see a lot of that in this course. Okay, so let's go ahead and look at the next statement on page 4. To simplify an algebraic expression, we combine like terms. I just mentioned the word like terms a second ago. Like terms are terms that have exactly the same variable factors. An algebraic expression is simplified. So this is example 8. Simplifying an algebraic expression. Simplify the following. Now, if we look at this carefully, looking at what we talked about a second ago, we cannot do anything inside these parentheses. Those aren't like terms. The variable factors are not the same. So this is a great example of why we use the distributive property. We're going to go ahead and distribute. And I'm going to skip that step, and I'm going to go ahead and just multiply in my head. The 7 times 3x squared is going to be 21x squared. 7 times 4x is going to be plus 28x. Okay, and I'm going to distribute the 9, so plus 45x squared, because 9 times 5 is 45, plus 18x. So what I did there in that first step was I used the distributive property, and I did the multiplication over the addition. Now I'm going to go ahead and combine like terms. So what I've done first was I removed the parentheses, and then now I'm going to combine like terms. So I'm going to go ahead and combine this term with this term because I have the same variable factors, the x squared. What I'm going to do is I'm going to take the 21 and add it to the 45, and I'm going to keep that variable factor. The 21 plus 45 is 66. That's 66x squared. Now I'm going to go ahead and combine these two terms, they both have the same variable factor of x. Take 28 plus 18, and I get 46. I get plus 46x. So again, an algebraic expression is simplified when the parentheses have been removed. I did that the first step by using the distributive property. And like terms have been combined. I combine like terms, and you are now done. You cannot add these two terms because they do not have the same variable factor. So my final answer is 66x squared plus 46x. Now if you actually write your answer as 46x plus 60, it doesn't matter what order your terms are, although it's more common to write it in this form. Right? We have brackets here, symbol, and you have them within each other. What you're going to do is you're going to actually worry about marks here. And I'm going to actually worry about getting rid of these parentheses around the x minus 3. Well, I have that minus down here, and out here, when you see a minus sign outside the parentheses, you can think of that as a -1 or a -1. And I'm going to distribute that to get rid of those parentheses. Okay, everything else just dropped down. So I have 8x plus 2 bracket 5. Now -1 times x is -1x or -1x. You don't have to put that 1 there, but I put it in there just to emphasize -1 or -1. And then -1 times -3 or -3 here in this case. -1 times -3 is going to be plus 3. And notice how the parentheses are gone. So now I'm going to worry about inside that bracket. I can actually combine like terms inside this bracket. There are like terms of 5 and 3. So I have 8x plus 2, and inside the bracket I have 8 minus 1x, and I'm going to go ahead and get rid of that 1 there. You can leave it in there if you want to, but it's 8 minus x or 8 minus 1x inside the bracket. There's nothing else I can do inside that bracket. There are no more like terms inside the bracket, so I'm going to go ahead and get rid of the bracket by using the distributive property. So I have 8x plus 16, because 2 times 8 is 16, minus 2x, because 2 times the -1x is a -2x or minus 2x. Okay? And I'm not done until all my like terms have been combined. These two are like terms right here. So now I have 6x plus 16. Again, 16 plus 6x is also an acceptable answer. So it doesn't matter. Homework for that section. If you have any questions, please feel free to email me.